Hey, this is going to be a quick video on the structural formulas and intermolecular forces practice test. So the first question asks you to draw the formula for carbon tetrafluoride, which is CF4. So you'll draw your carbon, you'll put your 4 fluorines around it, and then you need to figure out how many valence electrons you have. Carbon in group 14 has 4. Fluorine in group 17 has 7. So 4 plus 7 plus 7 plus 7 plus 7 is 32 valence electrons, or 16 pairs. So you put 1 pair between the carbon and each of the fluorines, and then you start distributing the rest of your pairs so that everything ends up with 4 pairs of electrons, unless you have hydrogen, which would only want 1 pair of electrons. So that's our 4 pairs. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Now each of our fluorines has 4 pairs of electrons, plus our carbon in the middle has 4 pairs. And number 2, for the N2 molecule. Each nitrogen has 5 electrons. That's 10 electrons, or 5 pairs. If you go 1, 2, 3, 4, 5, that's all the pairs we have, but this nitrogen is short 2 pairs of electrons, so we can borrow 1 pair from nitrogen and make a double bond, and borrow a 2nd pair from nitrogen and make it a triple bond. And number 3, drawing the carbonate ion. So we have 6 plus 6 plus 6 plus 4, plus there's a -2, so we add 2 more electrons to our count. That gives us 24 electrons, and that's 12 pair. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, this carbon does not have 4 pairs of electrons, so we need to make a double bond. So we could take like a pair off of the oxygen here and make a double bond. Or we could have done the double bond with the oxygen on the left. Or we could have bonded with the oxygen on the bottom. So those are our resonance structures. So we'll put some brackets around those, put some arrows in between them, and then since it had a -2 charge, we'll put a -2 on it as well. Number 4, asking about the BF4 minus. Boron has 3 valence electrons, plus 7, plus 7, plus 7, plus 7, plus a -1 charge. Add an electron. That gives us 32 divided by 2 is 16 pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And we just need to put brackets with a -1 for the -1 charge. And number 5, NH4 plus. If we add up our electrons, nitrogen has 5, plus each hydrogen has 1. But since it's a positive charge, we will take away an electron. So that gives us 8, or 4 pairs. And it looks like that. Number 6, silicon dioxide. We have 6 plus 4 plus 6 electrons, that is 16, or 8 pairs. So 1, 2, 3, 4, 5, 6, 7, 8. Silicon is still short 2 pairs of electrons, so we'll make a double bond there, and we'll make a double bond over here. Erase that all the way, and we're done. Number 7 is SO2, which has 2 more electrons than SiO2, so it's got 13 pairs of electrons. 1, 2, 3, 4, 5, 6, 7, not 13 pairs, 9 pairs of electrons. 8, 9. We make a double bond for the sulfur, but we could either make the double bond on the right hand side or on the left hand side. And then, since this is a resonance structure, we'll use brackets and arrows, and that one's done. And the last one on there was H2O. 6 plus 2 is 8, or 4 pairs of electrons. 1, 2, 3, 4. Now it wants to know the shape. In number 1, since we have 4 things attached to the central atom, that is tetrahedral. In number 2, if you only have 2 atoms, the only shape it can be is a line. That's linear. Number 3, we have 3 things attached, so that is going to be trigonal. And since there are no lone pairs of electrons on that carbon in the middle, it's going to be flat, trigonal, planar. Number 4, just like number 1, is tetrahedral, as is number 5. In number 6, the silicons and the oxygens will get on either side of the silicon. There are no lone pairs of electrons on the silicon, so that will be linear. Number 7 looks similar to 6, but this lone pair of electrons will push those oxygens away from it and make it bent. And number 8, with the 2 lone pairs of electrons, will also push those hydrogens away, making it bent. For number 10, it's wanting us to rank the intermolecular forces from strongest to weakest. The strongest is hydrogen bonding. And then we have dipole-dipole. And then we have dispersion. Now, in order to do problem number 11, first thing we need to do is figure out which intermolecular forces these things have. So if it has hydrogen bonded to nitrogen, oxygen, or fluorine, it's hydrogen bonding. So an example would be number 8, that has hydrogen bonding. Also, number 5 has hydrogen bonding. Anything that is bent or trigonal pyramidal would have dipole-dipole forces. That comes up in numbers 7 and 8. Those are bent. But that one also has hydrogen bonding. So this one, since it's bent, it has dipole-dipole. Now this one has dipole-dipole as well, but hydrogen bonding is stronger, so that's the strongest forces present. And then everything has dispersion forces. So all the molecules have dispersion forces, and if it's not dipole-dipole or hydrogen bonding, then dispersion is the strongest force. So the ones that are polar compounds are going to be, we have like number 5, that would be capable of hydrogen bonding. Number 7 would be capable, that would be polar. Number 8, that one would also be polar. All right. And that's the end of the worksheet.